All right, guys, we're going to do more word problems today. Go ahead and do number 1. Keep in mind when it has the sign of A here, it just won't say fraction or a ratio. So if you want, you can utilize this up here, or you can write it out as this: O over H, C is A over H, T is O over A, SOHCAHTOA. Then you can circle this, opposite, adjacent, hypotenuse. Okay, sine is O over H, so that'd be 12 over 20. You can simplify it too if you want. Okay, A over H would just be 16 over 20. O over A would be 12 over 16. Okay, and then to find the actual angle, this is the difference between the ratio and the angle. If I need the angle, that means we need to use the -1. So I can take any of these. Okay, I'm going to use this one, but to find the actual angle measure, I'm going to do tan -1 of 12 over 16. So when I do that, tangent -1, 12 over 16, you should get about 37 degrees. Now you could do that for any one of those. You could do sine -1 of 12 over 20, any of those that have A with it. Then whenever you're doing B, now these are going to switch. All right, so now this is opposite, this is adjacent. So sine, I would have 16 over 20. Cosine would be 12 over 20. Tangent would be 16 over 12. Angle B, if you do tangent -1 of 16 over 12, they should be complementary. Get about 53 degrees. All right. Down here, you're just setting them up. All right, I'd have, go ahead and solve A, B, and C, and let me know what you get. All right, so for letter A here, it should be sine 32 equals 5 over x, opposite over hypotenuse. You end up dividing, you get 9.4. This one, B, you're solving for an angle, so you do -1, the inverse tangent, because you have opposite and adjacent, 56.3. And this one, you have adjacent hypotenuse, cosine, you end up multiplying, you get 51.9. So now, we have two things here. I'm going to have the two vocabulary words. You're going to have angle of elevation, and we're going to have the angle of depression. So think elevation is up. You're elevating, you are looking up from there, and it's always from the eyes. From eyes. Okay, depression, you are looking down. So here, elevation would be the yellow. If I'm here, if I'm standing on the top of a building looking up, that's going to be my angle of elevation. So my E is looking up, and then the angle of depression is always looking down. But if you notice, okay, these lines, if you're looking off into the distance, these are parallel. So what I have are alternate interiors. So really these angles always equal each other because I will have parallel lines going in between there. The important thing is that I'm not going to use this top angle at all. So like not this one, but like if I were to extend this, there's very rarely will I use this green angle right here. Okay, so whenever there's an angle, make sure you are not putting it in the green part because any thing that's up here would be equal down there. All right, so I'm just going to label this. Looking up, this is going to be angle of elevation. If you're at the Ferris wheel looking down, this is angle of depression. And you can make your right triangles like so. This one, looking up on the mountain or whatever, that would be elevation. This would be angle of depression. They are always equal going through. Mark the angle of elevation and depression for each diagram. Find the missing piece of information. Okay, so this one, hot air balloon, this angle of depression looking down, again, we're going to have alternate interiors here. So this, I could actually bring this angle down inside alternate interiors. I could draw a Z here. And so these two angles would be congruent. So I could put the 36 here. All right, then go ahead and solve for the question mark. Okay, you should get 44.1 feet for that. On this next one, it's looking for this angle up here. So that is the angle of depression looking down on the outside. So this angle could actually flip down in here again. Okay, parallel, parallel. So this angle is the one that I'm searching for. Go ahead and solve for that angle. Okay, you end up using sine, inverse sine, because you have opposite and hypotenuse. Okay, sine -1, you should get 12 degrees. For this last one here, this is one of those elevated triangles. It's up off the ground, so make sure we pay attention to this guy right here. 5.5 feet. All right. So if I need X, this whole spot, keep in mind any kind of trig I do will only find what's in the right triangle. All right. So let's go ahead and see if we can get the final answer. So since I'm using opposite and adjacent here, I'm going to use tangent 25 equals opposite over adjacent. Cross multiply and solve. You get 16.8, but since this is elevated, if I need this whole height over here, I would have to add the 5.5 at the end to get 22.3. All right, read the following word problems while highlighting or circling each number. When you're done, place each number / variable in its rightful spot in each picture and finally solve the problem. So it says Sasha is standing at 345 feet. Spots a gazelle. Her eyes are 5.7 feet from the cliff. She has an angle of depression of 63 degrees. Okay, so I will say this. I'm going to be asking you where the 345 goes. Anything that's a circle here, any circle is an angle in any of these. So that represents an angle measure. So my question is, since this is a side length, it's only going to represent either the light green, the purple, the pink, the yellow, or the red over here. Okay, the 345 is standing on the top of a 345-foot cliff. So here's the cliff. She's standing on top of it. So the 345 is going to go there. Sasha's eyes are 5.7 feet from the cliff. So she's standing on the cliff. Where do you think that 5.7 would go? Cliff standing on it up to her eyes would be 5.7. All right. Her angle of depression is 63 degrees. Where do you think the 63 degrees? Since it's a degree measure, it's going to be either green, light blue, or the orange, because those represent, the circles represent the degree measures. Angle of depression, again, eyes looking down, would be 63 here, which then, since these are parallel, would transfer because I have the Z here. That would actually jump down to here. I know, lots of colors going on here. All right, but now I actually have a right triangle with a bunch of numbers. Okay, now it's asking how far away from the cliff is the gazelle. So I need to figure out what color represents how far away from the cliff is the gazelle. So here I've got cliff, I've got gazelle. To represent that would be here, the purple. All right, now to find the entire right triangle, all right, I would need the entire height here, because if I trace the right triangle, it's not just 345, it's 345 and 5.7. So if I go 345 plus 5.7. That would give me this red part here. So it would be 349.7. So now there's a lot of information. Okay, this is opposite. So I'm just going to use tangent of 63 degrees equals, okay, 349.7 over x. Now go ahead and solve for x. Okay, so guys, the most overwhelming part of this is just labeling where everything goes. And I even drew the pictures out for you here at the beginning. So once you get to this point, it's really one of the same old questions that we've done before. It's just a matter of placing the numbers in its appropriate spot. All right. So an airplane is 23,450 meters in the air. Power starts his descent. At what angle of depression, that seems like it should be something I should highlight, what angle of depression must he set for his plane if he knows that the straight line distance, now straight line distance, pretty much you're connecting the two things, from plane to runway. So this number here is going to be the number that represents the distance when you connect plane and to runway and connect the two dots for that straight line distance. All right, so now where would the 23,450 meters go? Okay, this much in the air, this would be the pink, 23,450. At what angle of depression, where would that go? Angle of depression would be the light blue, because it's looking down, which then, since these are parallel, would switch down here to the orange as well. Okay. Then 75,000 meters, so straight line distance. So I'm going to connect, it says that, plane, runway. Connect those two dots, that's going to be my hypotenuse, 75,000 meters. All right, go ahead and solve for the angle. Okay, since I have opposite and hypotenuse here, I'm going to end up using sine. Do the inverse sine to get 18.2 degrees. Down here, Austin is flying a kite in his backyard. He's trying to figure out how high his kite is from the ground when he lets all the string out. His hands holding the string are 6 feet off the ground, making a 32-degree angle. If the box, the kite came and says the kite string is 150 feet long, how high is the kite? All right, so the first question is going to be, where would the 6 feet off the ground go? He's holding it 6 feet off the ground. Boom. The next one is going to be, where does the 32 degrees go? So there's only one angle right there. Box says the string is 150 feet long. So where would this, what represents the string? How high is the kite? So I need the entire height. How tall is it off the ground? Boom. That would go there. All right, go ahead and solve for x. Okay, so then it's holding it 6 feet off the ground. So keep that in mind. Anything that's elevated off the ground, we are going to have to add in at the end. So this is opposite and hypotenuse. So sine x over 150. Get 79.5. Add 6, you should get 85.5.